So differentiability part 3. So this is the problem. F of x is x minus e into 2 power minus 2 by 2 power minus 2 by e minus x when x not equal to e, and is 0 when x is equal to e. So we have to check the differentiability of this function at x is equal to e. See now, as x tends to e, 1 upon e minus x tending to plus infinity is wrong. It may be plus infinity or minus infinity. That means when x tending to e, e minus x is tending to 0, correct only. But 1 by e minus x tending to infinity is wrong. It may be tending to plus infinity or minus infinity depending on this e minus x is tending to 0 plus or 0 minus. So anyway, that factor e minus x is appear here. So then better here as extending to e plus the behavior of this definition of the function, and as extends to e minus the behavior of the definition of this function is different. The behavior of the function is different. So better you find both left hand derivative and right hand derivative at e. Okay. So I'm finding left hand derivative at e, f dash of e minus limit extends to e minus, what is the definition? F of x minus f of a by x minus a. F of x, what is f of x? X minus e into 2 power minus 2 divided by e minus x minus f of e. F of e value is what? 0 divided by x minus e. X minus a means x minus e. So limit extends to e minus. Now what you will get? Here x minus e can I cancel? Then what you will get? 2 power minus 2 by e minus x. E minus x. Okay. So when extending to e minus, that means x value is smaller than e. Then e minus x tending to what? 0 plus. It is tending to 0, but it is positive. So then after applying the limit, what will get? E power minus 2 divided by 0 plus. Minus 2 by 2 power, sorry, 2 power. Minus 2 by 0 plus is minus infinity. 2 power minus infinity is 0. Similarly, if you find right hand derivative, same situation we will get here. But extending to what? E plus. When extending to e plus, e minus x tending to what? 0 minus, correct. Extending to e plus means x value more than e. Then e minus x is 0, approaching to 0, but it is a negative value. So e minus x is tending to 0 minus. The answer what you will get? 2 power minus 2 by 0 minus. So minus 2 by 0 minus is 2 power infinity. So 2 power infinity is infinity. So here left hand derivative not equal to right hand derivative, because left hand derivative is finite but right hand derivative does not exist because it is infinite. So what we can conclude? F is not differentiable at x is equal to a. F is not differentiable at x is equal to a. Okay, so at x is equal to e, sorry. F is not differentiable at x is equal to e. Okay, at the point x is equal to e. Suppose the same problem they may ask, find the domain of f dash x. For this problem, if they ask, instead of asking check the differentiability of this function at x is equal to e, if they ask what is the domain of f dash x, so here clearly f is differentiable everywhere except at e. So then the domain of f dash x becomes r minus e. The domain of f dash x. The domain of f dash x is domain of f dash x is all real numbers except e, because the domain of f is r. Then the domain of f dash x is r minus e, because f is not differentiable at e. That means f dash x does not exist at x is equal to e. Then e is not a member of domain of f dash x. Okay. So you try this problem. Find the domain of f dash x. Find the domain of f dash x. Given f of x is x by 1 plus mod x when mod x is greater than or equal to 1, and x by 1 minus mod x when mod x is less than 1. Okay. So this is you take homework. I think you copied. Next. This model problem is also important. Given f is differentiable at x is equal to a such that f dash of a is equal to 1 by 4, then calculate a limit h tends to 0 f of a plus 2h square minus f of a minus 2h square divided by h square. F is differentiable at x. F is differentiable at x is equal to a, and f dash of a is equal to 1 by 4. Then evaluate this limit. Okay. So here a is a constant. Okay. Now with respect to this limit, h is the variable, a is clearly constant according to the given data. A is a constant. So now if you apply limit h value 0, if you put, what you will get? F of a minus f of a, 0 by f of a minus f of a, what you will get? 0 by 0. So that means it is taking 0 by 0 form. We can apply L'Hospital's rule. So apply L'Hospital's rule, what you will get? Limit h tends to 0 f of a plus 2h square derivative f dash of a plus 2h square into a plus 2h square derivative, what you will get? 4h, because a is constant, derivative of a 0, derivative of 2h square with respect to h is 4h, minus f dash of a minus 2h square into what you will get? Minus 4h, because a derivative 0, derivative of minus 2h square is minus 4h divided by 2h. Okay, so don't apply once again L'Hospital's rule, because if you apply limit once again you will get 0 by 0 form because of this h. So better to take h common and cancel. Okay, take h common and cancel. So limit h tends to 0. So numerator 4h common, what you will get? F dash of a plus 2h square minus into minus plus, after taking a 4h common, f dash of a minus 2h square left divided by 2h. So h get cancelled, 2 1s, 2 2s. Now you apply limit, you won't get any 0 by 0 form. So 2 into, if you substitute h value 0, what do you get first term? F dash of a plus, again here if you substitute h value 0, what do you get? F dash of a. So f dash of a plus f dash of a is 2 into f dash of a. 2 into f dash of a into 2 is 4 into f dash of a. But what is f dash of a? 1 by 4. So 4 into 1 by 4. Answer is 1. Next, this type of problems are very important, especially for mains. Okay. So determination of function which are differentiable and satisfying given functional rule or functional equation. So f of x satisfies some functional equation or functional rule, and f is clear differentiable function. F is a differentiable and satisfying some given functional rule. Then for how to find such unknown functions? So f of x is some unknown function satisfying some given condition, means given functional rule, and we know that it is differentiable function. Okay, how to find that unknown function f of x? Using given functional rules. Okay, so here I am taking the help of derivatives. So what is f dash x formula? F dash x formula is what? Limit h tends to 0 f of x plus h minus f of x divided by h. Okay, so first write this formula and manipulate numerator according to the functional rule, then you will get f dash x value, then integrate, you will get f of x value, and use in given functional rule by putting x value 0, y value 0 or x value 1, y value 1 something, you will get f of 0 or f of 1 something. Using that f of 0 or f of 1 something, because you are getting f dash x, after integrating you will get some unknown constant in f of x, which is integral constant. To get that constant, so you find either f of 0 f of 1 based upon given condition. Using that f of 0 or f of 1, f of 3, two values, we can find that unknown constant c, so that we'll get f of x value. If they ask f of 1 or f of 2, f of 10 or f of 5 or f dash of 2, f dash of 3, anything we can find. After once if we got f of x, we can find anything. Okay, so here the question is, f is a differentiable function for all f is a differentiable function satisfying f of x by y is equal to f of x minus f of y, and is given, and also where x comma y positive, and also given f dash of 1 is 1, then find f of x. F is a differentiable function satisfying this functional rule where x and y are positive, f dash of 1 is 1. So as x and y are positive, and by looking this functional rule, no need to use this definition also, no need to use the f dash x definition also. By looking this, what we can take f of x, just identify them. Can we take k into log x? See, if you take k into log x, what you will get? Log of x by y. What you will get? Log x minus log y. Anyway, x and y are positive. K times of log of x by y is equal to k times of log x minus k times of log y. Correct? So from this functional rule, what we can take, f of x is equal to k into log x directly to the base e only you consider. Okay. Then what you will get f dash x? What you will get f dash x? K by x. K by x. So, and given what f dash of 1 is equal to 1. That means k value must be equal to what? 1. K value 1 means f of x should be equal to what? Log x. And to the base e only will have to take. Okay. Suppose if you take base a, k into log x to the base a, you will get log a. So k by log a is equal to 1. So then one possibility is what? Both k value 1, a value e. So f of x we can take log x to the base e. Okay. Or using above definition, second method. So consider first f dash x formula. F dash x formula is what? Limit h tends to 0, f of x plus h minus f of x by h. So limit h tends to 0. Now you can uல்டா condition, fx minus fy is equal to what? F of x by y. Like that, f of x plus h minus f of x, what we can write? F of x plus h by x whole divided by h. So further this can be written as limit h tends to 0, f of x by x is 1 plus h by x divided by h. Now if you put in the given condition, x is equal to 1, y is equal to 1, what you will get? F of 1 by 1 is equal to f of 1 minus f of 1. What you are getting? F of 1 by 1 is f of 1, 0. So that means that further this can be rearranged in numerator like this, f of 1 plus h by x minus f of 1. Can I write f of 1? Because f of 1 value anyway 0, divided by h by x into 1 by x. That means what I did? Multiply divided with x. Okay. So as h value 0, h by x value also what? Tending to 0. Then it is look like limit h tends to 0, f of a plus h minus f of a by h, which is nothing but f dash of a. Here what is a? 1 into 1 by x. What is f dash of 1 is given? 1. So thus what you will get? 1 by x. So f dash x is equal to what? 1 by x. F dash x is equal to 1 by x means blindly we can say that f of x must be what? Log x to the base e plus c. Means what I did? Integrating on both sides. What I did? Integrating on both sides. What you will get? F of x ln x plus c. Then how to find that unknown value c? Again use this condition. F of 1 is 0. F of 1 is 0. So if you put x value 1 here, what you will get? Ln 1 0, ln 1 0 plus c is equal to 0. C value what you will get? 0. Thus f of x is equal to log x to the base e or ln x. So this is a little lengthy procedure. That's why I did that another method also. Okay. By observation, f of x by y is f of x minus f of y. By observing that, I took k into log x. Next. Next, f of x is a differentiable function, satisfies the condition f of x plus y is equal to f of x plus f of y plus x square y plus xy square. And also suppose that limit extends to 0, f of x by x is equal to 1. And suppose that limit extends to 0, f of x by x is 1. Then find f of 0, f dash of 0, f dash of x and f of 3. To get all these values, first we need to find what? F of x. Okay. So clearly by putting x is equal to 0, y is equal to 0 in the given equation, you will get what? F of 0 is equal to 0. Am I correct? This is f of 0, this is f of 0, this is f of 0, this total part is 0. So f of 0 cancel, f of 0 is equal to 0. Okay. So I got one initial condition. Okay. Now using all these three conditions, I am going to find f of x. Okay. For that, you consider first f dash x formula. F dash x form is what? Limit h tends to 0, f of x plus h minus f of x divided by h. So limit h tends to 0. So what is f of x plus h? So here you put y value is h. Then what will you get? F of x plus h. F of x plus f of h plus x square h plus h x h square. This is f of x plus h minus f of x as it is divided by h. So f of x get cancelled. Better split the numerator. Okay. So limit h tends to 0, f of h by h. Why I am separating? To use this condition. Okay. X square h by h is x square. X h square by h is x h. Now applying the limits. According to the given condition, limit h tends to 0, f of h by h is 1. Because in limits, variables are dummy only. Okay. Here instead of x, y, z, whatever you put, no problem. No? So 1 plus, there is no h, so x square, x into 0, 0. That means, so thus what you got? F dash x value 1 plus x square. On integrating on both sides with respect to x, then what you will get? F of x, integral of 1x, integral of x square is x cubed by 3 plus constant c. Then how we can find constant c? By using this condition. Okay. So how we come to know put x is equal to 0, y is equal to 0 only? Just observation, that's it. Okay. So if you put 0, x value 0 on both sides, what do you get? 0. This is 0 plus c. So f of 0 value is 0. So c value what you got? 0. Therefore f of x is equal to what? X plus x cubed by 3. So now you calculate f of 0 value, f dash of 0 value, f dash of x value, f of 3 value. To get f of 0 and f of 3, put x is equal to 0. To get f of 0, put x is equal to 0 here. Already we got f of 0 is 0. And to get f dash of 0, put x is equal to 0 in f dash x. Already we got f dash x. Okay. To get f of 3, put x is equal to 3 in f of x. Over now. And the next one interesting problem. So in this, how we come to know we have to use differentiation only, because functional rules are given, some like functional equations are given, many methods are there. Every problem we can't using derivative definition, we can't find f of x or f dash x. Okay, so different formulas are there. In functions already have learned 4 standard formulas. Okay, so whenever f of x plus y is equal to f of x plus something f of y like that is there, then you need to get an idea. We have to consider f dash x only and manipulate numerator according to given functional rule. Okay. Next one, last one, interesting problem. So it is given f of x plus y is equal to f of x plus f of y plus 2xy minus 1. 2xy minus 1. And also given f dash of 0. F dash of 0 is equal to square root of 3 plus a square. 3 plus a minus a square. Here a is some constant, some fixed constant a. Okay. Then find f of x. And also show that f of x is positive for all x belongs to R. We have to find f of x and we have to show that f of x is positive for all real numbers x. Okay. So consider f dash x. F dash x is equal to what? Limit h tends to 0. F of x plus h. So here instead of y h, if I substitute, what will get f of x plus h value? F of x plus f of h plus 2xh minus 1 minus f of x divided by h. So I forgot, we need to get some initial condition also now. See, better we substitute x value 0, y value 0 only. Okay. If you put x is equal to 0 and y is equal to 0 in the initial condition, this is f of 0, this is f of 0, both are cancelled. Then this is f of 0, this is 0 minus 1. So 0 limit, f of 0 minus 1 is equal to what you will get? 0. If you put x value 0, y value 0, what you will get? F of 0 value is 1. Here plus f of x minus f of x both get cancelled. So limit h tends to 0. A small adjustment here. 2xh by h is anyway it is hh get cancelled, then limit will get exist. So better separate 2xh by h plus remaining part is what? F of h minus 1 by h. So limit h tends to 0, 2x is 2x only plus limit h tends to 0. A small adjustment. H I am writing 0 plus h minus 1 I am writing f of 0 divided by h. So it is look like f of a plus h minus f of a by h, which is nothing but f dash of a. Nothing but f dash of a means what? 0. There is 0 in a. So 2x plus f dash of 0. So this is f dash x. Then what will you get f of x? If you integrate x square, this is f dash of 0 into x plus constant c. To get constant c value, put x is equal to 0 on both sides. F of 0 is equal to, this is 0, this is also 0 plus c. So thus c value is f of 0, which is equal to 1. So thus f of x is equal to what you will get? X square plus f dash of 0 into x. F dash of 0 is what? Square root of 3 plus a minus a square into x plus 1. So thus we got f of x value. Now we have to show that it is positive. See, now it is a quadratic. It is a quadratic. So to show that it is always positive, see here, look at this. I am finding just it's a discriminant. Okay. So here f of x is what? Quadratic in x. Quadratic in x. So here x square coefficient is what? 1. Now we have to show that f of x is what? Positive. So clearly the graph of this function is a parabola, only an upward parabola, because x square coefficient is what? Positive. So x square coefficient positive means it is a upward parabola, and according to the question we have to show that f of x is always positive. That means we have to show that the graph of the function, that means this parabola, is completely above the x-axis. So to show that it is completely above the x-axis, so we need to show that this function f of x, this quadratic expression, has no real roots. Has no real roots means it is enough to show that discriminant less than 0. So it is better to show that discriminant less than 0 when a is positive. Then this is the graph of the function, so that f of x is always positive for all x belongs to R. Because we need to show that one only. To show that f of x positive for all x belongs to R, and this is the graph of f of x. Okay, so it is enough to show that discriminant negative. Here a is nothing but x square coefficient, not this a, don't get confused. Okay, so here it is enough to show that discriminant of this quadratic expression is negative. Okay, so if you find discriminant, what you get? B square. B square is what? 3 plus a minus a square minus 4ac. Minus 4ac means what you get? Minus 4 into 1 into 1 is 4. So if you simplify, what you get? 3 minus 4 minus 1. So first you write minus a square plus a minus 1. If you take minus common, you will get a square minus a plus 1. And clearly we can write this as a minus of a minus 1 by 2 whole square plus 3 by 4. Correct? So I am writing, expressing it into x square perfect square. In integration also we learn this. Okay. So a square minus a plus 1 can be written as a minus 1 by 2 whole square plus 3 by 4. So clearly inside the bracket, whatever it may be, for any real number a, it is positive. Into minus is there, so it is always negative. So it is clearly less than 0. So as a discriminant of this quadratic expression is negative and x square coefficient is positive, the graph of f of x must be look like this. So from this graph, what we can conclude? The function value is always positive. The value of the function is always positive for all x belongs to R. Therefore, f of x greater than 0 for all x belongs to R. And you take these problems as homework. Okay. Homework problems. Try these problems. So discuss the differentiability of the following functions. The first function is f of x is equal to mod x plus mod x minus 1 plus mod x minus 2. So that means you find where the function is differentiable and where the function is not differentiable. And second one, f of x is equal to maximum of 2 sin x comma 1 minus cos x. So third one, f of x is equal to e power mod x. These are one kind of problems. Next kind of problems, this is also homework. If f of x is equal to x for x less than or equal to 1, x square plus bx plus c for x greater than 1 is differentiable at x is equal to 1, then find b and c. So as it is differentiable at x is equal to 1, it is continuous also now. So you take continue, if it is continuous at 1 condition you will get. It is differentiable at 1, you will get one more condition. So using those two conditions you will get b and c values. And how to evaluate this? Draw the graph of y is equal to 2 sin x, y is equal to 1 minus cos x, and here in this problem x belongs to open interval 0 comma pi. Only on open interval 0 comma pi you draw the graph. Okay, then you take maximum part. only upper part of the upper curve only. Then automatically from the graph only you will come to know some sharp edges where we are getting sharp edges. So at those sharp edges the function is continuous but not differentiable. So thank you. With this I am going to close differentiability. I hope you understand this all 3 sessions. To understand total concept, so you watch from session 1 means part 1, part 2, then you watch this part 3 so that you can understand easily. Okay. If any doubts are there other than these problems, any doubts are there, please comment me. Thank you.